we're putting together using identities to solve trig equations. So we're going to be using the 8 trig identities that we know to replace something in this equation and then doing what we've been doing the last couple of weeks. So for example, if you look at number 1, we see here that we have a cosine and a sine squared. Right now we want to switch one of them so that it's the same thing as the other one. So because this is a sine squared, I know I have an equation using sine squared and cosine squared, which is the green one up on my chart. So what I want to do is replace my sine squared with the other part of this equation so that it could be a cosine, and then I can solve it like I have been doing. So what I'm going to do is subtract cosine squared from both sides so that I'm left with sine squared on just one side. So I know that sine squared is the same thing as 1 minus cosine squared. So this right here, the sine squared, I can replace with 1 minus cosine squared. So everything else stays the same. So instead of a sine squared, I'm going to put a parentheses there, and it's going to say 1 minus cosine squared. Oops. And I'm going to turn this into an x because this equation has x's in it. Okay, so now everything else is the same. I'm trying to solve for cosine. So right now I'm going to first distribute this 2 to both of these. This gives me 2 minus 2 cosine squared x. And this is going to be quadratic because this is a cosine squared and this is a cosine. So right now what I'm going to do is bring them all onto one side because I want one of the sides to equal 0. So I'm going to add 2 cosine squared to both sides. And I'm also going to subtract 2 from both sides. So I have 2 cosine squared. So be careful, you cannot add this 2 and the 3 because this is a cosine squared and this is just a cosine, so they're not like terms. So I have 2 cosine squared plus 3 cosine. And then I have 3 minus 2. These are like terms, so I can put those together. 3 minus 2 gives me a positive 1. And on this side, everything is canceled out, so this is just a 0. So this should look familiar. Because this is an ABC quadratic equation, this is going to be using the x box. So in my x box, a times c goes on top. A times c is 2. B goes on the bottom. This is 3. What two numbers multiply to give you 2, add to give you 3? 2 and 1. So then in my box, my a term, which is 2 cosine squared, goes in this first box. C term, which is 1, goes in the bottom right. And then the 2 terms I got for my x are going to go in the remaining 2 boxes. So this is 2 cosine and 1 cosine. And to figure out what I have left over, one of them is going to have a 2. So if I'm looking at my column and my row, this is the one that's going to be 2 cosine, because 2 can be divided by both of those numbers, but not in the column. This is 1 cosine. So 1 cosine times what gives me 1 cosine? This is just 1. 2 cosine times what gives me 2 cosine? This is just 1. And so I can factor this out to be, I have 2 cosine x plus 1, and then 1 cosine, which is just cosine, plus 1 equals 0. And now, just like in my other problems, I'm going to separate them into 2 equations and solve for cosine in both of them. So in this first one, I'm going to subtract 1 from both sides, divide by 2. I get cosine's negative 1/2. I'm going to look for 1/2 in my chart, and I get the reference angle of pi over 3. Negative cosine, when I use all students take classes, cosine's negative, it's going to be in the second and the third quadrants. So knowing that I want a denominator of 3, I can rewrite pi here as 3 pi over 3. And so then if I go in the second quadrant, I'm subtracting. So one of my answers is 2 pi over 3. And then if I go in the third quadrant, I'm adding. So my other answer is 4 pi over 3. And now for this one up here, cosine x plus 1 minus 1 from both sides. I have cosine x equals negative 1. 1 is not in my chart, so I know this is going to be a quadrantal angle. Cosine is x over r. And so I know that my x value has to be -1. So in my unit circle, my x is -1 right here, which tells me that my angle is pi. So here are my 3 answers for problem number 1. Okay, now let's look at number 2. So for number 2, I have cotangent x equals √2 cosine x. So again, we're using our trig identities. So cotangent can be rewritten, so it could be either rewritten as 1 over tangent or cosine over sine. Because this is a cosine, I'm going to use cosine x over sine. So I'm just replacing cotangent x with cosine over sine. Because this is a fraction, I want to get rid of the fraction. Right now this is being divided by sine. So to get rid of dividing by sine, I'm going to multiply both sides by sine. So this cancels out and I'm just left with cosine x. Over here I'm left with √2 cosine x sine x. So now, what I want to do is, again like before, make one side equal to 0. So let's subtract cosine x from both sides. This gives us 0 on this side. Over here you cannot subtract cosine x from cosine x sine x because these are not like terms. So we're just going to leave them as 2 separate terms. And again, this should look familiar. There's 2 terms. We want to see if there's something we can divide out of both of them. We can take out a cosine. So when we divide a cosine out of both of them, this one's left with √2 sine of x minus cosine x divided by cosine x leaves us with just 1. So just like before, we're going to split them up into 2 separate terms. We have cosine x equals 0, √2 sine x minus 1 equals 0, and we're going to solve each of them. So 0 is not in our chart. We know it's going to be quadrantal. Cosine x is x over r. So we're looking for when x is equal to 0. X is 0 on the y-axis, which is 0, 1, 0, -1. So our 2 answers here are pi over 2 and 3 pi over 2. On this side, we're going to add 1 to both sides. So you get √2 sine x equals +1. Divide both sides by √2. We have 1 over √2. We cannot have a root at the bottom, so we're going to multiply by √2 over √2. This gives us √2 over 2. So we're looking for when sine is √2 over 2. So in our chart, we can find that that is when the alpha is pi over 4, and we want this to be a positive sign. So sine is positive in the first and the second quadrants. So in the first quadrant, we just add 0 plus pi over 4, which gives us pi over 4. In the second quadrant, this is 4 pi over 4, and we're subtracting, so this leaves us with 3 pi over 4. So our 4 answers for this problem are pi over 2, 3 pi over 2, pi over 4, and 3 pi over 4. I want to do one last problem. So this one's a little bit different. We have sine of x minus cosine x equals 0. So if we were to add cosine x to both sides, we would end up with sine of x equals cosine x. So we're looking to see when our sine of x and cosine x are equal to each other. So if you look at your chart, we're looking for a place where your sine and your cosine are the same. So in your chart, they're the same when your alpha is pi over 4, because they both have √2 over 2, so they're equal to each other at that place. Now we also need to find out where they are equal to each other in the quadrant. So we want sine and cosine to both be positive or both be negative. So they're both positive in the first quadrant. That's where they're going to be equal to each other. In the second quadrant, sine is positive but cosine is negative, so that they're not equal to each other here. In the tangent quadrant, sine and cosine are both negative, so they are equal to each other. And in cosine, cosine is positive but sine is negative, so they're not equal to each other. So we're looking at these two quadrants using this reference angle. So here, our first quadrant, we just add 0 plus pi over 4 gives us pi over 4. In our third quadrant, we know that this is 4 pi over 4, so we're adding, and this gives us 5 pi over 4. So this is our answer for number 3.